Assalamualaikum warahmatullahi wabarakatuh. Today I will present for the team project Computer Architecture and Organization. Here is my team project members. My name is Norma Zatishazoni binti Zulkifli, B0324103113. Joyce Wong Ki, B0324104126. Narfatia Soleha binti Sulkana, B0324104110. And Brinda Sri Das anak perempuan Muruga Desen B03241041. First, introduction to MIPS assembly language programming. MIPS is a RISC architecture known for its simplicity and efficiency, making it an excellent choice for learning assembly language programming. As a load store architecture, MIPS performs all operations on data stored in register, requiring data to be loaded into registers before computation and stored back to memory afterwards. Each instruction in MIPS is 32 bits long, providing a uniform and predictable structure. The architecture features a straightforward set of instructions, including arithmetic, logical, memory access, and control flow operation, making it ideal for understanding fundamental concepts in computer architecture and programming. MIPS program also typically consists of two segments. First, the data segment for defining variables, and the text segment for executable instructions. Using tools like MARS, programmers can write, simulate, and debug MIPS assembly code, gaining hands-on experience with low-level programming and developing a deeper understanding of how software interacts with hardware. The source code. First, on data section. Data section defines the string, literal, and space used in the program. Prompt is the message asking for user input. Binary label, hash label, and oct label. The label indicating the output format for each conversion. New line is a string representing a new line. Octal output is an 8-byte buffer to hold the octal digit for letter printing. On the text section, which is main program logic, text section contains the program logic, main is and the entry point for the program. Next, $S00 for the initialize a counter $S020. This counter tracks the number of input processed. BGE $S0 10, then input check if the 10 numbers have been processed. If so, the program jump to the done input level to exit. Next, in the main program logic, this section prints the prompt message using syscall with code 4. If done, read an integer using call with code 5 and store the input in $T0. Next, we will be check if the input within valid range 0 to 255. BLT $T00 input underscore loop check if the input is less than 0. If true, it goes back to the input prompt. BGT $T0255 input loop check if the input is greater than 255. If true, it goes back to the input prompt.
Hello everyone, my name is Joyce Wong. I will explain about binary conversion. Start from the line 36. We have to load the syscall code for print string, then load the address for binary label. After syscall, the sentence of binary equivalent 8 bits will be printed out. Then we load with the highest bit 2 to the power of 7, that is equal to 128 into the register T1. So this will be checked each bit, either it is set or not set, from the most significant bit number to the lowest significant bit number. Here is the looping for binary conversion. So first, we perform the bitwise AND operation between the input number register T0 and the mask register T1. If the register T2 is equal to 0, Then we will go for the label print 0. To print 0, we have to load address 48 is for the ASCII value for character 0. Then we will write the syscall code for printing the character. After syscall, the character 0 will be printed out. So if the register T2 is not equal to 0, then the system will read to the next line. Load address 49 is for the ASCII value character 1. Then we will write the syscall code for printing a character. After this, we will be jumped to the next bit label. So here, we have to shift the value in the register T1 to the right by 1 position. This will move the mask 1 bit to the right, and it will check the next bit for the next loop. If the register T1 is not equal to 0, then we will go for the binary loop again. This whole process will be repeated until all the bits is checked and printed. So after this all, we will print for a new line so that the output is more clearly. To print a new line, we have to load the syscall code for printing a string. Then we will load the address of new line, which is already declared in the main function \n. So after syscall, the new line will be printing out. That's all from me. Thank you.